Welcome. 9 new cases of critical chain implementation. The first one we're going to talk about is a designer and manufacturer of textile processing and recycling machines. Fun stuff that I do is I discover how you do that, how you tear apart some clothing to be able to then reuse it. So recycling lines of cloth and stuff. So there's some fraying, some mixing, some compacting and stuff. These are long machines which go through the various stages, right? So it's, as you can see from the drawing down here, right? These things are about they can go from 20 to 50 meters long depending on what's involved. We did apply the theory of constraints to their organization, both in the way they designed their machines and in the way they assembled them, made them. They wanted to increase the production capacity because this kind of product the demand is skyrocketing because of recycling initiatives in various geographies, and they wanted to reduce the overall lead time because it was too long, and they wanted to also improve safety in the manufacturing. I'll come to that in a second. So what did we do? We applied, and this is going to be, I'm going to do this 9 times here. We applied the theory of constraints, critical chain, and lean, cocktail of all that. We changed the operating rules of the design office, in particular making sure that they work to full kit. That's something which I'll repeat many times in this webinar. Make sure that you have the full information, all the components you need and information you need before you start. That's full kitting. It's absolutely key to go faster and get it right and improve quality and so forth. So the critical chain approach was deployed across the entire portfolio and throughout the process, from the initial discussions with the clients, including a call for tenders, so a little project that would run a couple of months maybe to reply for a call to tender. Then it would be designed in the design office, and then it would go through production. Well, there'll be purchasing of all the different components and production, and the whole thing end to end was put into a critical chain plan and executed as such. Okay. We also worked on the sales and operating planning and medium-term planning to make sure we had a better sequencing of projects and didn't overload the system. And we put in new KPIs in the design office and in the methods and engineering and in manufacturing. So that's what we did. That's one of their fever charts there, as you can see. The reductions in the types of projects and their durations between 40 and 48% there. Lead times in the design office down 40%. Global lead times down 30%. On-time delivery or finishing started quite low at 35 and got to 100%. First, the initial bottleneck was the engineering department, and that was opened up significantly in terms of what was coming out of it, which meant that the production also became constrained. So they started having very long assembly lead times, and they had flooded their factory with semi-assembled machines. They considered that their floor space was a constraint, and that would limit how many machines they could make and sell a year. But in fact, when you looked at it, this was not true. It was only true because it was full of semi-finished, partially assembled machines, and we see that very often, right? So the problem is not the lack of floor space, it's the fact that your assemblies are taking a lot too long because you're not using full kit. So we applied full kit this time in manufacturing. We did not start assembling one of these machines until every single component of that machine was available. As a result, it used to take 9.5 weeks to assemble one of these. It's not the machine, it's in fact module by module of these machines. 9.5 weeks was reduced to 2 weeks simply by applying full kit and a few other basic lean ideas. This increased the productivity by over 30% for most of the main big runners. It also enabled to have a standardized, repeatable assembly sequence, which significantly contributed to safety, because the reason they were worried about safety is that they used to assemble things in the order the parts arrived. So sometimes they would get into dangerous physical positions under the machine or whatever when they were adding something that had just arrived. All we did was make sure that they worked in a very rigorous way, a standard way, assembling these machines, and so it was faster, cheaper, and safer. And because of that, as you can imagine, if it only takes 2 weeks where you used to take over 9, there was no longer a problem of floor space in the assembly areas. Problem solved. Let's go to a completely different domain now. This is a company in France that is about 600 people or so, and they develop and implement software, ERP softwares in industry and CRM softwares for all kinds of businesses. They develop them, update them, and also implement them. But the implementation is done by themselves and also a large network of partners. So they wanted to go faster. They had trouble keeping up with the significant increase in demand for these products. In this particular case, we had a system which has a 3-level solution, and we quite often do this sort of thing, and there are other videos specifically about this control pyramid principle. You have at the top level what we call a control tower, which looks at over the next 12 months, 18 months or whatever, and has a portfolio fever chart. That's to keep the overall view of what's going on. This is the tool that you use to decide the project staggering. That's to say the very important question of, if I win a new order, when do I start it? I don't start it necessarily as soon as I win it. I start it when the engineering department and or the production department is ready to take it in, right? You don't throw things down the line. You make sure that there's the resources are available. So we did do that. Then in the middle level is critical chain planning. With you see clearly the different stages of the process, and you manage the projects with the critical chain way, which gives you good deadlines and so forth, and makes it much easier. Again, today's subject is not to describe how critical chain works, but people at this level feel usually they're running around like firefighters, right? If you have critical chain, you actually know what's going on, and you feel you're in control of the situation. That's that medium-term thing. Down and on the daily management level, there's all sorts of project checklists and other visual management systems implemented to manage day-to-day operations. Okay, this pyramid with also applying certain of the rules of flow. Have a look at the annexes of this presentation if you wish to know more about the rules of flow. There's, for instance, a book on that subject. But some of them that we were using in this project was staggering, making sure you're very careful about when you launch a new project into the system. Dosage, full kit, and of course the critical chain and the fever chart that I presented. Okay, that's it. The results were for their 2 different businesses. For the ERP projects, we've already done a reduction of over 30% of the duration. It's probably going to go further than that. That's just the initial results after the first year or so of implementation. And the CRM projects are already 40 to 50% and still getting faster and faster. So those were the results. It meant that everybody felt they were much more in control. And in fact, it's become a competitive edge, because now they feel confident that they can do this at these speeds. They're selling that idea. They're saying, "Hey, we're good at implementing these things faster than other people, so that you don't have to fear what is a big trap of ERP in particular." So that's in our second case.